the first notes we're going to take today deal with integration of inverse trig functions. And the bottom line is you just need to memorize these, okay? You're going to memorize, recognize the pattern, all right? So I've got a square root. It doesn't have this number outside. It's just that. I'm going to let a is equal to the square root of 16 is 4. U is equal to the square root of x squared. And I plug things in, and I have the arc sine of u over a plus c. Oh, there's a 3 up here. You can wrap that to the front, which means it's right here. Let's change that so you can read it. Okay? All right, the next one. You've got a plus sign in it. This has got a plus sign. So, and you got a 2. That 2 can get wrapped to the front. A is equal to the square root of 4. U is equal to 5x. You plug it in, so you end up with a 2 times 1 over a arctan 5x over 2 plus c. And of course those go away, so you have just the arctan of 5x over 2 plus c. All right. Oh, square root with something in front of it. Oh, looks like it follows that pattern. Are they always this obvious? Pretty darn close. Okay. There's no number on top this time. I'm going to let u equal x. And a is equal to the square root of 7. Ooh. That works. All right. So now you have 1 over a. Arcsecant. Absolute value of u over a plus c. And you do not need to rationalize them unless it's a multiple choice. And the rationalized version's there. All right, this one's a little more difficult. You have to recognize it's not a natural log. You're not going to let u equal 8 plus 9x squared. It follows this pattern right here for arctangent. And a would equal the square root of 8, and u would equal 3x. This 8 wraps to the front. Okay, so now I have 8 times 1 over a arctan of u over a plus c. If I try and rationalize this, you'd multiply top and bottom by the square root of 8, and then the 8's cross out, so you end up with the square root of 8 times the arctan of 3x over the square root of 8 plus c. All right, you have a worksheet on this. It's just a matter of practicing. The worksheet has this box on the top, so just find the pattern and practice them. Memorize them so you remember what's what. Okay? All right, next part of our lesson is a little refresher along particle movement along the x-axis. These are things we know from before, and we're going to add 2 things to it, okay? It says, when does the particle change direction? Velocity is equal to 0. So in order to determine where the particle changes direction, you'd find set v of t equal to 0. When the particle moving left, this is positive or negative. Okay, so you set v of t equal to 0, then make intervals. Right, so it goes from 0 to a to b, b to whatever, right? And you plug values into the v of something and determine if it's positive or negative. Determine when it's speeding up or slowing down. V of t and acceleration, velocity and acceleration are same. It speeds up. When v of t and a of t are different, slows down. Total distance, I can integrate from a to b the absolute value of the velocity function, because if you integrate velocity, you get position. You take the derivative of a position, you get velocity. They work backwards. And the absolute value is important. That's as long as you have a calculator, you can do this. If you don't, you have to integrate a to b, v of t going right. And where, let's say b to c, v of t, dt. This is when it was going left. And you're going to add them together. Add absolute value. We have an example of that on the next worksheet. To determine displacement, you can just integrate a to b of velocity, and it will take care of your pluses and minuses, right and left. Because displacement, so if I started here at 0 and I go over here to 10, and I come back to 4, my displacement is only here. So I went 10 in this direction, 6 that direction, I end up at 4. The integration will take care of your displacement. Okay? If you've got a function you don't know how to integrate, then you have to find your position function. We'll figure that out. We got it. To find the equation for acceleration, they gave you velocity and you want acceleration. You take the derivative. If they give you velocity and you want position, you're going to integrate. Don't forget the plus c. Okay? All right, that's a little review of stuff we already did. Now comes the part that's a little bit different. Okay? All right, we start out talking about a honeybee. He's flying from his hive to the flower garden. He gets nectar. He comes back. And then he rests a minute. He goes back. All right? So he traveled, and this is velocity. This is minutes. If you do feet per minute times minute, they cross out, and you get the total, the feet. So he traveled 200, came back 200, went 200, came back only 100. So his total distance is 700 feet. His displacement, he went 200 this way, 200 that way, 200 this way, came back 100. So his displacement is 100. His position is 100 feet from where he started. Okay, if he had come back 150, this would be 50. All right? Just a good concept to think about. All right. We now have a particle moving along the x-axis. They gave us the acceleration function. They said at time 0, the velocity is 24. And at t1, the position is 20. It says write the expression for the velocity of the particle at any time t. Well, remember the integration of acceleration gives you a velocity. So I'm going to integrate 6t minus 18 dt, and I get 3t squared minus 9t plus c. And it tells me at 0, it equals 24. So I plug in 0 for t, and you get c is equal to 24. So my velocity equation is 3t squared minus 9t plus 24. Okay? When is the particle at rest? Well, you set your velocity function equal to 0. Factor out that 3, and you get t squared minus 9. No, you factor out the 3, sorry. How come I have 3? This should be 18. Sorry, this is 18. Typo. Hate it when I make mistakes. Okay, 18. This should be 18. So this is 18. When you factor out 3, you get 6t plus 8. That looks better. And when I factor, you get t minus 2. Oh, jeez. T minus 2 and t minus 4. So when is it at rest? T equals 2 and t equals 4. Okay, write an expression for the position. You integrate velocity. You get position. So I'm going to integrate 3t squared minus 18t plus 24. And I get t cubed minus 9t. There's that 9t. I knew that was coming. 9t squared. Is that right? Because I add to it and you divide by it. So, plus 24t plus c. It tells us at time equals 0. No, at t equals 1, the position is 20. So you get 1 minus 9 plus 24 plus c equals 20. And you end up with c is equal to 4. So my position function is t cubed minus 9t squared plus 24t plus 4. It says find the total distance traveled. Okay, total distance. If you have a calculator in your hand, you can do 1 to 3, the absolute value of the velocity function. Okay, so let's put the velocity function in here. And I put it in my calculator, so remember you turn it on, you push that the option button, math button, and then you got to find absolute value. And y'all probably, okay, so absolute value, and then I've got 3t squared minus 18t plus 24 from 1 to 3, and it tells me it's 6. Okay, well, if you don't have a calculator, you've got to decide when it changes direction. So let's come back up here to velocity and just determine which direction it's going. From 0 to 2, and then I have 2 to 4. Okay, if I plug 1 into my velocity function, so this is negative, that's negative, so you get a positive value. If I plug 3 in here, that's positive and that's negative, so this is negative. So he's moving right, and he's moving left. So down here, I have to integrate from 1 to 2 the velocity function to give me his total distance. So that equals t cubed minus 9t squared plus 24t from 1 to 2. Okay? And it gives me, that equals 4. Okay? So what do you have? You have 8 minus 36 plus 48 minus 1 minus 9 plus 24. And you get 4. Then you got to integrate, let's change colors. Integrate from 2 to 3, because he's going in the other direction, of 3t squared minus 18t plus 24. And you get t cubed minus 9t squared plus 24t from 3 to 2. Hello, 3 to 2. So that's what, 27 minus 81 plus 72 minus 8 minus 36 plus 48. So what do we get? 27 minus 81 plus 72. So this is 18. And you have 8 minus 36 plus 48. You get 20. It equals negative 2. And when you add them together, you add the absolute value. All right? So it's the absolute value of 4 plus the absolute value of negative 2. It gives you 6. This and this should match. Okay? You don't know how to do this without a calculator. You don't know how to do absolute value integration. So chances are on an AP exam you'd have to do this by hand. But you have a calculator in your hand, you can show your work. Find the displacement Displacement, all you have to do is integrate from 0 to 4, the velocity function. Oh, I've got to change colors again. So what do we get? T cubed minus 9t squared plus 24t from 0 to 4. 0, it all goes away, right? So 4 cubed is 64 minus 16 times 9 is 144 plus 96 gives me 16. So that's where he's only 16 feet away from where he started. Alrighty. Oh, but we got to add. Oh, it didn't ask position. That's displacement. If he asked for position, he started at 20. So you have to add 16, and he's standing at 36. Okay? That's if they ask for position. This is displacement. All right, not too bad. Just a lot of busy work. All right, a bug crawls up a vertical wire at a time t0. The velocity of the bug at time t is given by the function whose graph is below. Time is in minutes and distance is in feet. When does the bug change direction? Well, remember, this is the velocity function. So you change in directions when it equals 0, so that's at t equals 6. The total distance traveled, well, you got to find these. So this is 2 times 3 is 6, divided by 2 is 3. Got 2 by 3 is 6. This one's 3. There's 2 by 1, half of that is 1. So the total distance is 3 and 6, 9, 12, plus 1 is 13. Okay. If he started crawling from the garden at 0, how high up the wire is? He's at 8. He's talking about displacement. So he went up 12, came down 1, so he's at 11 feet. Okay, that's displacement. All right, last problem. You're given the velocity function. Determine when the particle's moving left, right, and stopped. So first you got to determine when it stopped. So when is 5 cosine t equal to 0 on the unit circle? The cosine's 0 here and here. So t is equal to pi over 2 and 3 pi over 2. I'm going to make an interval from 0 to pi over 2. Pi over 2 to 3 pi over 2. And 3 pi over 2 to 2 pi. Okay, this is a cosine. Cosine in this quadrant is positive. It's negative in that. It's positive here. So we have right, left, right. Find the particle's displacement. You can integrate from 0 to 2 pi. It's 5 cosine t dt. So this ends up being 5 sine of t from 0 to 2 pi, which is 0 minus 0. So there's no displacement. It came right back to where he started. Okay? Find the total distance traveled without a calculator. So therefore, I've got to integrate from 0 to pi over 2, 5 cosine of t dt, which gives me 5 sine of t from 0 to pi over 2. I'm going to get the same thing, 5 sine of t from pi over 2 to 3 pi over 2. And 5 sine of t from 3 pi over 2 to 2 pi. So the sine of pi over 2 is 1. So that equals 5. The sine from at 3 pi over 2 is 1. No, it's negative 1. here is minus 1. So I got negative 2 times 5 is negative 10. The sign at pi over 2 is 0. 3 pi over 2 is negative 1, so it's minus a negative 1, so that's 5. Okay, so if you want to do total distance, you take absolute value and you get 20. And if you go back up here and talk about displacement, he went right 5, left 10, right 5, and he ends up right back where he started. Okay, so this and this check. Here's a quick summary. If you want to do displacement, you can just integrate velocity. If you need total distance, you have to use the absolute value, and you have to have a calculator. If you don't have a calculator, you have to integrate the parts, okay, right and left, and take the absolute values and add them together, okay? That's what there is to particle motion and integration. Good luck on the worksheet.